No questions? Okay. Next week on Thursday, there will be an exam. Um, you'll have the in-class and the take-home part just like the others. It'll be the last exam and then a final. I don't know if there'll be any take-home part on the final because you do have 2.5 hours for the final. But the exam will be November 11th during class. Is there any questions? It will be over chapter 7, which was 7.1 and 7.2, and then chapter 8, which is only 8.2, and then 9.2. So we just do beginning of derivatives, and then we do the applied problems in chapter 8 and 9 for business applied. Any questions? Chapter 8 and 9 talk about relative extrema, which is the highs and lows on your graph. So if it says relative extrema, it wants all the possible max and mins on the graph or the equation. It's your highs and lows. When you're naming them, it's a relative max of your y value at your x value. So if X value was boxes of candy and Y is the profit, you have a maximum profit of a certain amount when you sell however many boxes of candy. So you put your maximum first, and that's the Y value. X is the value that gets you there. Same thing with min. Now if we look at a couple of the graphs to tell when there's a max and a min, it's where you're increasing and decreasing change. So if you're increasing and then decreasing, you have this high part here. Whereas if you're decreasing and then increasing, you have a low spot. And those are the ones that give you your max and your mins. So if we look at number 5, it's increasing and then it's decreasing. So there's a high right here, which means there's a relative max of, and then you use the y value. The y value, if I look at the top of this graph, it goes across to the 3. So there's a maximum of 3 at -4. So I'm using the point -4, 3. That's where this high point is on the graph. Now there's higher points because this keeps going up, but this is one point where there's a relative max. This one has a relative min here because it's going down and then up. So anywhere where you're increasing and decreasing change, those are where you have max and mins. So this one here is a min. And then we use of the y value, so a relative min of 1 at -2. Any questions on that? Let's try number 8. We look at number 8. The graph's decreasing until we hit -3, and then it increases. So right here is a max or min. Because this is a low point, it's decreasing and then increasing, like we have here. It's a min. So we have a relative min of the y value is 0 at the x value is -3. Any questions? Now we're increasing until we hit right here on the y-axis where we start to decrease. So we have a high point here because increasing and then decreasing. And you can tell when it's making a hill, it's a high point or a max. When it's a valley, it's a low point or a min. So this would be a high point. The y value 1, 2, 3 is 4. So there's a relative max of 4 at 0. Any questions on that? So the last one, we're decreasing and then increasing. So this is a min, and it's a min of 0 at 3. Now we already have a min at 0, so we have 2 of them. Notice they're both reaching the same y value. So you can put them together. Even MyLabs, a lot of times it will have you put them together. Relative min of 0 at -3 and 3. Any questions on that? These x values, they're called critical numbers. But any questions on reading the graph? So these x values that give you your relative extrema or your max and mins, they're called the critical numbers. Critical numbers are the x values that give you the max and the min. To find them, if we don't have the graph, when you want to find them, you take the derivative, set it equal to 0, and solve. So just like when we were finding the slope of the tangent line where it's horizontal, that's where, if you look at number 6 again, that's where the highs and lows are, because that's where your tangent line would be horizontal, because it only hits at one point. So they go together. Take the derivative, set it equal to 0, and solve. The x values are your critical numbers. To find the y values, plug it back into the function. Now, normally it's the original function, but remember, sometimes we have cost and price, and we have to find revenue and then find profit. So it's not always the original. It's the one right before the derivative. So go to your derivative and take the one before. And that will find your relative max or min. And I think it doesn't start till chapter 9, but I'm not sure. There might be some in 8. To find the absolute max or min, which means the highest value or the lowest value, because if you can look at number 6, it's a high value on the graph, but this is part here with that arrow is going to keep going up. So depending on what my bounds are, this might not be the highest value. If I only went from 0 to 4, it wouldn't be my highest value. So the first thing you do when you want to find the absolute max or min in an interval, you find the critical values. Take the derivative, set it equal to 0, and solve. Then you plug in A, B, your 2 endpoints, and any critical values between A and B. So if one of your critical values is outside, you don't use it, because if you have to go between 0 and 20, and you have 25, 25 is too high, you're only using the values between 0 and 20. So you only want the critical values in this interval. And you plug them into the function right before the derivative. The largest y value is an absolute max, the smallest is an absolute min. Give you a second to write it. Any questions?
Go
Let's
back for
try.
just a second so I
Sure.
could screenshot that.
Mhm.
Thank you.
You're welcome. So we're going to do number 17. It says, find the x value of all points where the function defined as follows have any relative extrema. Find the values of the extrema. So we want to find the max and mins. 17. Now some of these, if you go into you can open this through as you learn, and then go into My Math Lab, and it's called e-text, and you can open up your book. But you need to be careful because some of them we haven't learned, like number 21, 22, and 20. Oh, 23 is fine. 21 and 22, it's a quantity to an exponent. That's a chain rule. We didn't cover that. We didn't cover exponential or natural logs. So there was a lot of derivatives. We only touched on it, the simplest part of it. Um, so there are some problems if you're just opening up the book that we haven't covered. But if you ever have a question, just let me know. Number 17. F of x equals -4/3 x cubed minus 21/2 x squared minus 5x plus 8. Okay. So the first thing we need to do is find the critical numbers. To find the critical numbers, we need to take the derivative. So go ahead and take the derivative. So when you check the derivative, 3 times a -4/3 is a -4x. Subtracting 1 from the exponent, you get a 2. And then the next one, 2 times 21/2 is a -21 x to the first. This one is a 1. 1 times -5 is a -5. And then it would be x to the 0. So it's just -5. And the constant is also 0. So you should have gotten -4x squared minus 21x minus 5. Any questions on that part? Then we need to set it equal to 0. Now this one is factorable, so you could factor it. But since it's quadratic, which means the degree is 2, I would use the quadratic formula. That's 51. You can use the quadratic formula in your calculator, or you can use the formula -b plus or minus the square root b squared minus 4ac all over 2a. And if you do have the TI 83 or 84, I emailed someone showing the directions, but you can also Google it. Just say the steps to put the quadratic formula in the calculator. Also, depending on which one you have, if you have the cords to hook to your computer, you can also load them from the website. under program, you'll go over to new, and that's where you would create it. If you want to look at it, they'll have you prompt. I think now you can just put a comma b c. I'm not sure. Notice the quadratic formula is in there. Negative b plus the square root b squared minus 4ac divided by 2a, and then the minus. And then you display them. And then second and quit. So I guess you could always go back and look at my steps, because I am recording it. But under program quad, then you run the program by hitting enter again. So you have to enter twice to run it. Then it asks for a, -4. Just make sure you use the negative, not the minus sign. -21 and 5. And I must have done something wrong. Did I write it wrong? -4.
It's supposed to be -5.
That's it. Because it works out nice. Oh, it do have a -5 here. I just wrote it wrong. Thank you. Be careful. That should be a -5. Let's try again. Because this one should come up with 1/4 or -1/4. Try again. Program quad. And it's very easy to delete things on your formula. So before a test, I would always check it in case you have to fix something. But you should get -5 and -0.25 or 1/4. So these are the two critical numbers. Any questions on that? So you can plug it into this. You can factor it. It's also factorable. This is a cubic function. A cubic function, the arrows go in opposite directions, like 5 and 6. If your degree is odd, your graph will resemble 5 and 6 with some bumps in it. If it's an even graph, it resembles a parabola. Both ends go up or both ends go down. In this case, this odd one would look like number 6 because it's decreasing because of that negative on the highest degree term. So because that's negative, it would be going this way. This would be a positive x cubed. Or any odd degree, x to the 5th, x to the 7th, will resemble these two graphs. So we know that this graph is going down. Now we know that there's two bumps in it because we got two critical numbers. That's where your increasing and decreasing change. And we know it has to start coming down because this is negative. So by having an idea of what your graph looks like, you can easily tell if these will give you a relative max or min. This is coming down and then going up. Thinking of your number line, -5 would be here and -0.25 would be here. So this one's will give a relative min, this will give a relative max. So you don't even have to graph it. You can think about what the graph should look like. To find the y values, you need to look where your derivative is and plug into the one before it. So we're plugging into this one. You can go under y equals, and I have these from yesterday. So -4/3 x cubed minus 21/2 x squared minus 5x plus 8. And then second in table, I'll delete what was there, and I just want a negative 5 and negative quarter. If you need more decimal places, you just highlight it. So it's a negative 62.83. And that's a min. So there's a relative min of negative 62.83 at negative 5. Other one is a max. So there's a relative max of 8.61. At x equals negative quarter. Any questions on that?
Can you show again how you got those two numbers?
These two numbers?
Yeah, with the calculator.
So under y equals, I put the equation, the original one, right before my derivative. I typed it under y equals. And then I went second in table. And then I typed my two x values. Negative 5 and negative 0.25.
Thank you.
You're welcome. Now, if it's not letting you type in values, you need to go to, I think it's table set. Yeah. You need to hit second and table set. What's happening if it's not letting you enter them, then you have auto highlighted. So you just want to go over to ask, hit enter, and it will change it to letting you ask or asking you for the value. And once you do that, then it'll let you type them in. Any other questions? We'll do another one. Any questions on getting the values? Now, if you did want to graph it, looking at the values I have, my x values are going from a negative quarter to negative 5. So negative 10 to 10, those would be in there. Now this one, notice it's going all the way to a negative 62. So you could put a negative 65 here. I have a negative 90 because another problem it'll work good for. But you want to make sure that whatever you, like this y values, if I had negative 10 to 10, you're not going to see this. It's too large. It's not in that range. So you want to make sure your x's and your y's are in this range. 10 works because this is only 8. But the negative 10 for the y can make it a negative 65, something larger than this, or further out than this. It's actually smaller. But then when you hit graph, you can see them. Which is similar to what I had here. This is the negative 5, and this is the negative quarter. Any questions on that? So you really didn't need the graph as long as you have an idea of what your graph looks like. Okay, let's try number, I think it was 19 I wanted to try. Yeah. Okay. So x to the fourth minus 18x squared minus 4. So the first thing we want to do is find the critical numbers by taking the derivative and set it equal to 0. So go ahead and take the derivative. C was -5. I don't know. I just saw that. No, notice when you take the derivative, it's not a quadratic. So you can't just use the quadratic formula. This was similar to one of the ones on the group assignment. So 4x cubed minus 36x to the first, and this goes to 0. Any questions on the derivative? To find the critical numbers, we take the derivative and set it equal to 0. Well, a lot of times when you're trying to solve, if you have it equal to 0, you want to try and factor. We can pull an x out. In fact, we can pull a 4x out. So sometimes you have to pull what they have in common out first and then try and factor again. And if we pull a 4x out, here we'll have x squared. And here we'll have a -9. And then we can set both of them equal to 0, or you could factor this further. This is the difference of squares. Any questions so far? Once you have it factored, you could set each of these equal to 0. So 4x equals 0, x minus 3 equals 0, and x plus 3 equals 0. Divide by 4. And get 0. Subtract, well, this one we have to add the 3. And then subtract this one. You get 0, 3, and -3. Any questions on that? What you could have done instead of factoring here, you could have put the 4x equal to 0, which gives us 0. And then x squared minus 9 equals 0. You could solve by the square root method. Add the 9 over, and then take the square root of both sides. But what you have to remember when you take the square root of both sides, you have to be careful you don't lose your plus or minus. So when you take the square root of both sides, it leaves a positive and negative square root of 9, which is a positive and -3. So although this is a great method here, sometimes you lose the one. So be careful. But either way works. You're still getting 3 of them. Any questions on that? So when your degree, whatever your degree is, you usually end up with your degree minus 1 critical numbers. Sometimes they repeat, but if none repeat, you'll have, in this case, 3 of them. The degree is even, which means it's resembling a parabola. That the largest degree term is positive, which means both ends are going up. And we're turning 1, 2, 3 times. So it's going down, up, down, and it has to end going up because it has to resemble a parabola. This would be the -3. This is the 0 and the 3. So we have two relative mins and a max. Any questions on that? So these are your critical numbers.
Whenever you have like a coefficient in front of like the x squared or the x cubed, how do you factor that again without just like guessing and kind of, is there like an easier way to?
Okay. Well, this one I would just pull it out, but this one. We used the X when I taught it earlier this semester. And so you multiply your first and last term. -4 times a -5 is a +20. And then -20 is the, 21, middle term. So it's the first times the last, and then add to get the middle. So we want two numbers when we multiply, we get 20, that when we add, we get a -21.
Okay, I forgot to multiply the -4 times the -5. I know how to do it from there then.
Now, the other thing you have to remember is because there's a number in front, once you find the multiplication, you have to divide by this. And this gives a +1/4. Putting the x in the bottom, it'll be 4x plus 1. And then this reduces to a +5/1. So it's just 1x plus 5. I think this is the easiest method I've found for factoring when there's a number in front. Any other questions on that? The only thing is if you can't find two values that work, then you still got to go back to your quadratic formula. And the quadratic formula always works. So this formula is one you want to be used to in case it's not factorable. Any questions? So we have our critical numbers, 0 and ±3. And we know whether they give mins and maxes. To find those, though, you need to plug them back in. You see where the derivative is, and you take the one value before. So if we, calculator, go to our calculator. And if you don't have a calculator where you can store the y values, you just plug them in. Plugging in 0, we get 0 minus 0. So 0 is a -4. Relative max of -4 at 0. So you can just plug them into here. For the +3, 3 to the 4th minus 18 times 3 squared minus 4. It's just the calculator's a little quicker. I already stored it. So under y equals, you type the equation, x to the 4th minus 18, x squared minus 4. And then second in table, and we want 0, -3, 0, and 3. So we get a -85, a -4, and a -85 again. So our relative mins are at the exact same value. So we have a relative min of -85 at 3 and -3. Any questions on that? 44. Yeah, on number 44, it says in exercises 43 to 46, find the number Q of units that produces the maximum profit, the price P per unit that produces the maximum profit, and the profit. So we want to find out how many, the price we're going to sell them for, and the profit that we'll make. Number 44 here, we're given the cost. When it doesn't say, you can assume dollars per unit. Yeah, it's just in dollars. 25Q plus 5,000 and price, because it's a lowercase p, equals 90 minus 0.02Q. Q is just per unit. Now it wants us to find profit, maximum profit. Well, to find profit, we need revenue and cost. We don't have revenue, but we have price. So remember, revenue is price times your quantity. My price is 90 minus 0.02 Q. And my quantity is Q, because Q is the number of units. Any questions on that part? Oh, it's distributed here. I'm going to distribute the Q. So we'll have 90 times Q, which is 90Q. And negative 0.02 Q times Q is Q squared. So this is our revenue. Any questions so far? So we have revenue. We need profit. Remember, profit is revenue minus cost. My revenue, 90Q minus 0.02Q squared, minus my cost, 25Q plus the 5,000. Now you need to be careful because you have to subtract all of your cost. So it needs to be in parentheses. Any questions so far? Now, when you distribute this negative, you can make this a positive and change both signs. That way you don't forget. I'm also going to put them in, I like them in decreasing order or standard form. I like to put the Q squared first, so negative 0.02 Q squared. And then the 90 minus 25 is a positive 65 Q minus the 5,000. Definitely one that you would not want to try and factor. So you would have to use the quadratic formula. And any questions on that part? Because we want to maximize the profit, we need to find the critical number. Now notice this is quadratic because the degree is 2. It's a parabola and it's negative. A parabola that's negative looks like this. which means one, there's only one critical number, and two, it's the vertex. You've learned a lot of ways of finding vertex. So you could use x equals negative b over 2a. That would be using the algebra. Now we're doing the exact same thing, but using calculus. So to find this high point, or the x value of the vertex, you just take the derivative. Negative 0.04q plus 65. Oh, I said, we don't need to set this one because it didn't ask. That would give us our x-intercepts. I was graphing in my other class and I forgot. We don't need to graph it. We just have to find the vertex. So setting this equal to 0 gives you your x-intercepts. The derivative gives you the vertex. And this is a nice one to solve. Just subtract the 65 over. Did you have a question? So to find the critical number, you have to take the derivative and then set it equal to 0. If we would have set the here, we would have just found the x-intercepts. But we want the critical value. The degree is only 1, so we can just get q by itself. Subtract the 65 and divide by the decimal. So 1,625 units will maximize our profit. Any questions so far? And that's why I did a lot of these ones, setting them up earlier so that you'd be more comfortable when we added the calculus. Part A asked for the number of units that will give you the maximum profit. Part B wants the price that you will sell them for. Well, price is P. And if we look back at our original, here's the price. 90 minus 0.02 Q, and Q is 1625. So we'll sell them for $57.50 each. Any question? Oh, yeah. The 65, I subtracted it to the other side. Because this is a plus, you subtract it. And then this was being multiplied, so I divided it. Thank you. Any questions on the 1625 or the 5750. So part B wanted the price we would sell them for, and then part C wanted total profit. So it's always good to label your equations. If they want cost, I use this one. If they want revenue, I'd use the simplified one, this one. For profit, I'd use this one. So P of 1625 would be this one. Negative 0.02 times 1625 squared plus 65 times 1625 minus the 5,000. Two times 16. I heard it right. Are you getting 47,000 in sum? Negative 0.02 times. Yeah. Any questions on that? Let's try number 47. On July 11th, 2014, the power used in New York State in thousands of megawatts could be approximated by P of T equals a negative 0.006088 T cubed plus 0.1904 T squared minus 1.076 T plus 18.39. Okay. Where T is the number of hours since midnight. And T has to be between 0 and 24 because they're only dealing with one day. Find any relative extrema for the power usage as well as when they occurred. So they want us to find the max and the min in the first 24 hours. First thing, find your critical numbers. To find the critical numbers, take the derivative, set it equal to 0. Three times this decimal is a negative 0.018264 t. Subtracting 1 from your exponent, you get a 2. Then 2 times the second decimal point, 194 times 2. And then 1 times this one, negative 1.076. T to the 0 drops off, and so does our constant. Any questions on the derivative? When we set the derivative equal to 0, that will give us our critical numbers. I'm not going to try and factor it. I'm going to use the quadratic formula. Any questions so far? Thousands of megawatts. So when you find your critical numbers, you get 3.37. Okay, let me write it. 490,592. The other one is 17.4792685. Now it doesn't specify if you should round it to hours or use the decimal. T is the number of hours since midnight. 3.4 and 17.5. So the critical values are at these. Now what we need to make sure of, because we are only going from 0 to 24, is to make sure they both fall in there, and they do. We have 0 and 24. That's our endpoint. So I always take the endpoints and put them in a table, and then I take any of the critical numbers that are between, and they both are 3.4 and 17.5. Now to find the peaks or the megawatts, you take these and you plug them into the one before the derivative, which in this case is the original. So you plug 0, 3.4, 17.5, and 24 into here. Put it under y equals. And I've already typed it in. But under y equals, you put the original, and then second in table, and we needed 0, 3.4, 17.5, and 24. So these are all highs and lows on the graph. 18.39, 16.69, 25.24. and 18.07. But they are in thousands of megawatts. So our low one, which is the 16.69, 34, 16 point. Now it's thousands of megawatts. So you would either write 16.693 thousands megawatts, or you'd multiply by 1,000. $16.693 megawatts. You multiply by 1,000 to get the 16,693. So if you're not going to write 1,000 megawatts after it, then you have to multiply by 1,000. $18. Any questions on that? This would be our absolute max. This is our absolute min. It just asks for a relative extrema. So this one would be a relative min and a relative max. But in this interval, it's also the absolute lowest and the absolute highest. Any questions on that? Did you find those y values? I went under y equals and I typed the equation, the original, -0.0. It's down here because I had other equations, but -0.006088 t cubed. You want to always use x. Even though there's other variables here, you have to change your, you get your mode to different things. So I always stay with x. But type the equation in y equals, and then just second in table, and then you plug in your values. You're welcome. So anytime you have to plug in a bunch of numbers into an equation, use y equals. And type your equation, go to second in table, and plug in your x values. Now, if it's only one, then maybe you don't want to type the table, just plug it in here. But in this case, we'd have to be plugging 4 of them in, so it's a lot faster to do it this way. Any questions on that one? Okay. Number 51. 51 states, suppose that the cost function for a product is given by C of x equals 0.002 x cubed plus 9x plus 6912. So suppose the cost function for a product is given by this. Find the production level, i.e. the value of x that will produce the minimum average cost per unit. So minimum average cost. which means we have to find average cost, because if we find the minimum of this is total cost. Average cost, remember that's when we divide by X. And they even give you a hint. They show you the C with the line over it. So first we have to find the average cost function. Which means you take the function and divide by X. A couple ways we could do this. We could do the, well, this is the function. Any questions on the function? To find minimum, you need to find the critical value that gets you your minimum. And to find that, a couple ways we could go about it. We have to take the derivative. But there's only one term and it's only an X. We could divide this X into each of them and then have just the power rule rather than the quotient rule. I'm going to go with the quotient rule because we need to practice it. But you could have divided this X into each of these and done it, but then you have a negative exponent. I don't know, it might be easier to solve this way. So to find the critical numbers, we need to take the derivative. Remember, it's I'll just write it here. Bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Bottom, just X, times the derivative of the top. 3 times this is 0.006x squared plus 9. So the derivative of the top is multiply these, and we get 0.006x, subtract 1, and get a 2. This is a 1. 1 times 9 is 9. X to the 0, and the constant drops off. Minus the top, 0.002x cubed plus 9x plus 6912 times the derivative of the bottom. What's the derivative of x? Anyone? What's the derivative of the bottom? 1. Yeah. Because when we take 1 times 1 and get 1, x to the 0 falls off, so it's just 1. All over the bottom squared. So that's our derivative. If you want to simplify it, you can. Since we have to set it equal to 0, that's probably a good idea. So I would distribute the x here and get 0.006x cubed plus 9x. And then here I'm distributing a -1. So I have a negative 0.002x cubed minus 9x minus 6912. All over x squared. I do have 9 x's that will cancel, and the cubes can be combined. 0.004x cubed, the 9 x's cancel, minus 6912 over x squared. Now, if I just ask for the derivative, I will accept any one of the three. And if you have to plug in values, I will accept you plugging into any one of the three. But if you have to set it equal to 0, you're going to have to be able to simplify it. Any questions on the derivative? What's nice about doing it this way, when you set it equal to 0, if you have a fraction, the only way it's going to be 0 is if the top is 0. We can't have 0 in the denominator. So when you're setting a fraction equal to 0, you can just set the top equal to 0. Now, if you don't want to do it that way because you don't know what you're doing with x squared, when you have a fraction equal to anything, to get rid of the denominator, we would multiply both sides by x squared. That way the x squareds cancel. And notice we have our top equal to 0. So it's the same thing, you just set your top equal to 0. Any questions on that part? Now we want to solve this, so we're going to add the 6,912 to the other side. And divide by 0.004. Any questions up to there? Okay. We have a cube. How can we get rid of the cube? Anyone? There's two ways you can get rid of it. One, you can take the cubed root of both sides. Now, when this is odd, it's not a plus or minus. It's only whatever sign it is. Plus and minus is only for even root. So you could take it, the cubed root of both sides. Or you could take each to the 1/3 because an exponent to an exponent is multiplied. 3 over 3 would just be 1, which would leave x. So either way, you either take it to the third or you take the cubed root. And you get 120. D1. Find the production level that will produce the minimum average cost per unit. So the production level is 120 units. If you keep producing groups of 120, that's your minimum cost. Any questions on that? Positive. Question. See if we have time for one of these. Okay, there's one like this on the group assignment, and there's one on your test, which is next week. So I want to go over number 15. This is in 9.2. And we have a few minutes. We'll go over it quickly. A local cub is arranging a charter flight to Hawaii. The cost for the trip is $1,600 each for 90 passengers. So if they have 90 passengers, they charge $1,600 each. So we could find the revenue if there's only 90. The price is $1,600 times the 90 is 144. So at 90 passengers, they charge $1,600 each. It would be $144,000 in revenue. Because remember, it's price times quantity. Now it says there's a refund of $10 per passenger for each passenger in excess of 90. Now there's a couple ways you can find this value. You could let X be the total number of passengers, or you could let X be the number of passengers over 90. When you let it be the number of passengers over 90, your equation's a little bit easier for revenue. Because if it's total passengers, then you have to subtract it from 90. And I think it's a more complicated problem than if you let it be the number of passengers over 90. Revenue is price times quantity. Now our price, X is the number of passengers over 90. The price is $1,600 minus $10 for each person over 90. So we only have to put X here instead of having the quantity 90 minus X and have to distribute. Let X be the number over 90. So then you just have to use an X here. So it's 1,600 minus $10 for each person over 90. Our quantity then is not just X, because that's only the passengers over 90. We also have the 90 passengers. So this would be 90 plus X. Any questions on that? So I think it's simpler letting X be the number of passengers that are over, because then that discount's only 10X. But now you have to FOIL this. Or we could use the product rule, because we need to find the number of passengers that will maximize the revenue, which means we need to find the critical numbers take the derivative, set it equal to 0. I'm going to take the derivative first to practice. Remember, it's the first times the derivative of the second plus the second times the derivative of the first. The first is 1600 minus 10x. The derivative of the second is 1. Because the 90 goes to 0, and derivative of x is 1. Plus the second, 90 plus x times the derivative of the first. The derivative of this is a negative 10. We have distributing the 1600 minus 10x. And here we have a negative 900, distributing the negative 10, and negative 10x. Combine like terms, negative 20x plus 700. I think it was much easier. My numbers stayed smaller. If I would have FOILed here, I would have had to use a calculator. So I used the product rule to take my derivative, combine my like terms, and this is the marginal revenue. This gives me my critical numbers by setting it equal to 0. Any questions on that? So real quick, when we set it equal to 0, negative 20x equals a negative 700, because I just subtracted to the other side. And then divide by the negative 20. X equals 35. Now remember, X is the number of tickets over 90. So 35, our quantity was 90 plus X. 35 plus the 90, 125 tickets. And to find your revenue, 1600 minus 10 times 35 and 90 plus 35. We would plug in here. So even though we're taking off the price, we're only putting 90 people at 1600, that's 144,000. This is 156,000. So the people are paying less and we're making more. Any questions on that? So it'd be 125 tickets will give us a revenue of $156, $156,250. Any questions on that?